Welcome to Math with Mr. J.
In this video, I'm going to go through a mini course on evaluating expressions. We will cover expressions with one variable, two variables, numbers next to variables next to variables, expressions with exponents, and expressions in fractional form. So we will go through a bunch of examples. We will start with some basic introductory examples and then go from there. Everything is put into chapters and time-stamped, so feel free to jump around. Now, to evaluate an expression, that just means to find the value of the expression, so what it equals once we work through it. So let's start with our intro section, and then we will move on from there. Let's jump into number 1, where we have x plus 22. Now for numbers 1 and 2, we need to evaluate these expressions, or find the value of these expressions, when x equals 5. The first thing that we need to do, we need to replace or plug in the given value for the variable. That's called substitution. So for number 1, let's plug 5 in for x and rewrite this expression. So we have 5 plus 22. Now we can evaluate. So we find out what this equals. 5 plus 22, that equals 27. So the value of this expression is 27 when x equals 5. Let's move on to number 2, where we have 8x. Now we have a number next to a variable. That means we are multiplying. So this is 8 times x. Let's plug in and evaluate. So we have 8 times 5. 8 times 5 equals 40. So the value of this expression is 40 when x equals 5. Now, one thing I do want to mention about number 2, when we plug 5 in for x, make sure to use something to represent multiplication. I used a dot. We can't put those two numbers together, the 8 and the 5, to represent multiplication. That would look like 85. We can only put a number next to a variable to represent multiplication. So something to keep in mind. Let's move on to numbers 3 and 4, where we have two variables and multiple operations. We will start with number 3, where we have 7b minus a, so 7 times b minus a. Let's start by plugging in the given values for a and b, and we will rewrite this expression with those substitutions. So 7 times b, well, b equals 9, so plug in 9, minus a equals 10, so plug in 10. Now we can evaluate, but we have more than one operation. We have multiplication and subtraction, so we need to use the order of operations, PEMDAS, in order to work through this. So parentheses, exponents, multiplication and division, then addition and subtraction. Multiplication comes before subtraction, so let's multiply first. 7 times 9 equals 63. Then we can bring down the subtraction sign and the 10. We end with 63 minus 10, that equals 53. So the value of this expression is 53 when a equals 10 and b equals 9. Lastly, let's move on to number 4, where we have a plus 18 divided by b. Let's plug in and evaluate. A equals 10, so plug in 10 for a, plus 18, divided by b equals 9, so plug in 9 for b. We have addition and division, so we need to go through the order of operations. Division comes before addition, so let's divide first. 18 divided by 9 equals 2. Bring down the addition sign and the 10. So we end with 10 plus 2. 10 plus 2 equals 12. So the value of this expression is 12 when a equals 10 and b equals 9.
So there's our intro section. Let's move on to some examples with one variable. Here is our section with expressions with one variable.
Let's jump into number 1, where we have 2 next to parentheses that include 3m minus 5. Now, whenever we have a number next to a variable like 3m, that means they're being multiplied. So we have 3 times m. And then we also have the 2 next to the parentheses. So that means we have 2 times whatever we get within those parentheses. The first thing that we need to do is replace or plug in the given value for the variable. This is called substitution. So let's plug in 4 for m and rewrite this expression. So we have 2 parentheses, and remember, this means 2 times whatever we get within the parentheses. 3m, which means 3 times m, so 3 times, and then m equals 4, so plug that 4 in, minus 5, end parentheses. Now we are ready to evaluate, so let's figure out what this equals. Since we have more than one operation, we need to use the order of operations, PEMDAS, to work through this. So parentheses, exponents, multiplication and division, then addition and subtraction. So do we have any parentheses? Yes, so that's our priority. Now we have multiplication and subtraction within those parentheses. Multiplication comes before subtraction, so let's start with 3 times 4. 3 times 4 equals 12. Bring down everything we did not use, so the subtraction sign, the 5, the parentheses, and the 2. We still have subtraction within the parentheses, so let's do 12 minus 5 next, which equals 7. I will keep 7 within parentheses and bring down the 2 we did not use. So we have a 2 next to a 7 in parentheses. That means we are multiplying, so we end with 2 times 7, which equals 14. The value of this expression is 14 when m equals 4. Let's move on to number 2, where we have 10m plus 32 over m. Now we have one variable, m, but it's in 2 places. So when we plug in, we need to make sure we plug in that value for m in both of those places. For this expression, we have a number next to a variable, so we are multiplying here. We have 10 times m, and then we have a fraction. We have 32 over m. That means we are dividing. We have 32 divided by m. Let's plug in and evaluate. So we have 10 times m, which equals 4, so plug in 4 for m, plus 32 over m, or 32 divided by m. Again, m equals 4, so plug in 4 there as well. Now we can evaluate, so let's figure out what this equals. We have multiplication, addition, and division. We don't have any parentheses. We don't have any exponents. Again, we have multiplication and division, so that's where we are going to start. Multiplication and division come before addition. Well, we have both. So what we do, we work our way from left to right. We start with whatever comes first. So let's do 10 times 4 first. 10 times 4 is 40. Bring down everything we did not use, so the addition sign, and then the 32 divided by 4. So now we have addition and division. Division comes before addition. 32 divided by 4 equals 8. Bring down the addition sign, and the 40. We end with 40 plus 8. 40 plus 8 equals 48. The value of this expression is 48 when m equals 4. So there's our one variable section. Let's move on to two variables. Here is our section with expressions with
two variables.
We are going to evaluate the expressions when g equals 7 and h equals 5. Let's jump into number 1, where we have 42 over g plus 8h. Now 42 over g, that means 42 divided by g. 8h, that means 8 times h. The first thing that we need to do is replace or plug in the given values for the variables. This is called substitution. So let's plug in 7 for g and 5 for h and rewrite this expression. So we have 42 over g, let's plug in 7 for g, plus 8h. So 8 times h, let's plug in 5 for h. Now we can evaluate. So let's figure out what this equals. Since we have more than one operation, we need to use the order of operations, PEMDAS, to work through this. So parentheses, exponents, multiplication and division, then addition and subtraction. As far as the order of operations, we don't have any parentheses, we don't have any exponents. So the next priority would be multiplication and division. We have both. So what we can do, we can work from left to right. So division comes first, so let's do 42 divided by 7 to start off. 42 divided by 7 equals 6. Bring down everything we did not use. So the addition sign, the 8, the multiplication sign, and the 5. Now we have addition and multiplication. Multiplication comes before addition, so let's multiply next. 8 times 5, that equals 40. Bring down the addition sign and the 6 that we did not use, and we end with addition. So we have 6 plus 40, that equals 46. So the value of this expression is 46 when g equals 7 and h equals 5. Let's move on to number 2, where we have gh, so g times h, minus, and then in parentheses, 23 plus h. Let's plug in and evaluate. So we start with g, let's plug in 7 for g, times h, plug in 5 for h, minus, parentheses, 23, plus h, so plug in 5, and then end parentheses. So now we need to go through the order of operations in order to evaluate this expression. Do we have any parentheses? Yes, so that is priority number 1. Let's start there. We have 23 plus 5, that equals 28. Bring down everything we did not use, so the subtraction sign, the 5, the multiplication sign, and the 7. So now we have multiplication and subtraction. Multiplication comes before subtraction, so let's multiply next. 7 times 5, that equals 35. Bring down everything we did not use, the subtraction sign, and the 28. So we end with subtraction, 35 minus 28. That equals 7. The value of this expression is 7 when g equals 7 and h equals 5.
So there's our two variable section. Let's move on to expressions with numbers next to variables. Here is our section with numbers next to variables.
As far as a number next to a variable, simply put, it means to multiply. Let's jump into our examples and see exactly what this looks like. Starting with number 1, where we have 8x. We have a number, 8, next to a variable, x. This means they are being multiplied. So we have 8 times x. The first thing that we need to do in order to evaluate this expression, we need to replace or plug in the given value for the variable. This is called substitution. For the examples in this video, we are going to evaluate for when x equals 9 and y equals 2. So let's plug in 9 for x and rewrite this expression. We have 8 times x. Well, x equals 9, so let's plug in 9 for x, then multiply. 8 times 9 equals 72. The value of this expression is 72 when x equals 9. One thing I do want to mention about plugging values in for variables when we have a number next to a variable, make sure to use something to represent multiplication. For example, I used a dot. We cannot put two numbers next to each other in order to represent multiplication. For example, in number 1, if we were to put the 8 and the 9 next to each other, that would look like 89. That does not mean 8 times 9. When we have a number next to a variable or a variable next to a variable, that does represent multiplication though. So something to keep in mind. Let's move on to number 2, where we have 3xy. So we have a number next to two variables. This still means multiplication. We have 3 times x times y. Let's evaluate this expression. So let's plug in and go from there. We have 3 times x equals 9, so plug in 9 for x, times y equals 2, so plug in 2 for y. Now we can multiply, and I'm going to work from left to right, starting with 3 times 9, which is 27. Bring down the multiplication sign and the 2 we did not use. We end with 27 times 2, which equals 54. The value of this expression is 54 when x equals 9 and y equals 2.
So there's our numbers next to variables section. Let's move on to our variables next to variables section. Here is our variables next to variables section.
For our examples, we are going to evaluate the expressions when x equals 10, y equals 2, and z equals 4. Let's jump into number 1, where we have xz. Now we have variables next to each other. This just means they're being multiplied. So we have x times z. So whenever variables are next to each other, this represents multiplication. Now that we know this is multiplication, the first thing that we need to do as far as evaluating this expression is to replace or plug in the given values for the variables. This is called substitution. So let's plug in 10 for x and 4 for z and rewrite this expression. So 10 for x times 4 for z. Now we can evaluate. So let's figure out what this equals. 10 times 4 equals 40. So the value of this expression is 40 when x equals 10 and z equals 4. Now, one thing I do want to mention about plugging in the values for the variables, make sure to use something to represent multiplication. For example, I used a dot. Putting the numbers next to each other would not represent multiplication. For example, the 10 and the 4 next to each other would look like 104, not multiplication. Whenever we have variables next to each other or a number next to a variable, that does represent multiplication though. So something to keep in mind. Let's move on to number 2, where we have x, y, z. So x times y times z. Let's plug in and evaluate. So we have x equals 10 times y equals 2 times z equals 4. Now we can multiply. We will multiply from left to right. So we can start with 10 times 2. That gives us 20. Bring down our multiplication sign and the 4. Then we end with 20 times 4, which is 80. So the value of this expression is 80 when x equals 10, y equals 2, and z equals 4. So there you have it. There's how you evaluate expressions with variables next to each other.
Let's move on to the expressions with exponents section. Here is our section on expressions with exponents.
For our examples, we are going to evaluate the expressions when x equals 3. Let's jump into number 1, where we have 4x squared. So 4 times x squared. Remember, that exponent tells us that we are multiplying the base, which is x in number 1, by itself a certain number of times. The exponent tells us how many times. For example, let me come to the side here. X squared means x times x. We expand that base out however many times the exponent tells us, and we multiply. Now that we know what that exponent means, the first thing that we need to do as far as evaluating this expression, we need to replace or plug in the given value for the variable. This is called substitution. So let's plug in 3 for x and rewrite this expression. So we have 4 times x squared. Plug in 3 for x, and then that exponent of 2. Now we can evaluate. So let's figure out what this equals. Exponents come before multiplication as far as the order of operations go. So let's start with 3 squared. 3 squared, well, that means 3 times 3. 3 times 3 equals 9. So 3 squared equals 9. Bring down everything we did not use, and we end with multiplication. So 4 times 9, that equals 36. The value of this expression is 36 when x equals 3. Let's move on to number 2, where we have x cubed minus 5x plus 25. Now x cubed, that means x times x times x. Let's plug in and evaluate. So x equals 3. So we have 3 cubed minus 5 times x. So 5 times 3 plus 25. Now in this expression, we have an exponent, subtraction, multiplication, and addition. So let's work through the order of operations. Do we have any parentheses? No. Do we have any exponents? Yes. So let's start there. We have 3 cubed. So let's come to the side here. 3 cubed, well, that means 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. So 3 times 3 times 3 equals 27, or 3 cubed equals 27. Let's bring down everything we did not use. Now we have subtraction, multiplication, and addition. Multiplication comes before addition and subtraction, so let's do 5 times 3 next, which equals 15. Bring down everything we did not use. So now we have subtraction and addition, which are the same priority, so to speak. So what we can do, we can work from left to right. Subtraction comes first in this expression. So let's do 27 minus 15 next. 27 minus 15 equals 12. Bring down what we did not use, and we end with addition. 12 plus 25, that equals 37. The value of this expression is 37 when x equals 3.
So there's our section on expressions with exponents. Let's move on to the expressions in fractional form section. Here is our section on expressions in fractional form.
For our examples, we are going to evaluate the expressions when x equals 6 and y equals 10. Let's jump into number 1, where we have 6x over x minus 3. Now that fraction bar just means division. We have the numerator, the top, divided by the denominator, the bottom. So we work through the top, work through the bottom, then divide. You can think of this as the fraction bar splitting the expression into two groups, the top and the bottom, the numerator and the denominator. Work through each using the order of operations and then divide. Now that we know that we will be working through the top and the bottom, then dividing, the first thing that we need to do is replace or plug in the given values for the variables. This is called substitution. For number 1, we have one variable, x, but it's in two different places. Let's plug in 6 for x and rewrite this expression. We will start up top where we have 6x, which is 6 times x. That's going to be 6 times 6 over x minus 3, so 6 minus 3. Now we can evaluate, starting with the top. So we have 6 times 6. Let's work to the side here. 6 times 6 equals 36 over 6 minus 3. Now we can work through the bottom. So this is going to equal 36 over, 6 minus 3 equals 3. So we have 36 over 3. 36 divided by 3. That equals 12. So the value of this expression is 12 when x equals 6. To recap, we worked through the top, then we worked through the bottom, and we ended by dividing. Let's move on to number 2, where we have y squared minus 20 over x plus y. Let's plug in and evaluate, starting with y squared. Let's plug in 10 for y. So we have 10 squared minus 20 over x plus y. So plug in 6 for x plus 10 for y. Now we can evaluate. Let's start with the top. So we have 10 squared minus 20. We have an exponent and subtraction. Exponents come before subtraction as far as the order of operations go, so we need to start with 10 squared, which means 10 times 10. So 10 squared equals 100. So let's work to the side here. Starting with the top, so 10 squared equals 100 minus 20 over 6 plus 10. Now we can subtract. So we have 100 minus 20. Let's continue down here. So subtract 100 minus 20. That equals 80 over 6 plus 10. Now we can work through the bottom. So we have addition. This is going to equal 80 over 6 plus 10 equals 16. So now we have 80 over 16, or 80 divided by 16. That equals 5. The value of this expression is 5 when x equals 6 and y equals 10.
So there you have it. There's our mini course on evaluating expressions. I hope that helped. Thanks so much for watching. Until next time, peace.